So we will record this and we will share then this again with the people to have chance for people who had no chance to meet us to see this. So Pavel, you start recording, yes?
Mm-hmm. I'm stop sharing right now. Yeah. There is the link for in the chat. I send the link for the Mentimeter. We have two initial questions on you, and I hope I can do this the voting on Mentimeter for you. You can either use the link or you can use the code of our meeting.
So welcome all, because we prepare two questions on the beginning and then more questions after our presentation, which will be for us some feedback and also some possibility for future cooperation. The same questionnaire is also published on our webpage, so people will have chance to react on this also later. Seems that today we have a really balance of different groups of people. It is very interesting. I think that we can wait some few seconds and we will move slowly, Pavel, to other question.
Mm-hmm. I'm trying to. Hopefully, right now. No. This one? Yeah. And this is the next question.
Okay, seems that similar like on the first webinar, probably the personal sharing of information is the most effective. Yes, that most of people learn from the friends. As you probably know, this is the second round of our webinars. First webinar was focused mainly on e-infrastructure. Record of this webinar is already on our web pages, so you can see all this very interesting presentation from us on web pages. There were introduced on one side all infrastructure which was developed during EUXDAT and which is now running and will run also after end of the project. Today we will speak about agroclimatics model developed by meteoblue. And then we'll continue with two other webinars tomorrow morning and on Tuesday afternoon, where will be presented other pilots. So we at the beginning presented the technology, and now we are presenting pilots, but you will have chance to see again all from your houses when you will have time to look and discuss. So Pavel, I think that we can close, and I will now share my screen and make some introduction around before we will start. You now all heard that Commission brings this this Green Deal initiative, and part of this is initiative Farm to Fork and also Green Common Agriculture Policy. I will tell a few words at the beginning as some motivation for other presentation. About Green Deal, you can see, you know, probably this image very well. There are different areas where Green Deal is affecting, and Green Deal in principle started from something what came I think 2 years before. It was Sustainable Development Goals of United Nations, and this is in some line, and now they will be some number of obligation for countries, but also for farmers. The goal of Green Deal in agriculture are very ambitious, and you can see that they is expected reducing about 50% risk chemicals, pesticides, reduce nutrient losses at 50%, reduce usage of fertilizer and other things. Yes, so this is not very easy task. On other side, in sustainable agriculture, there is necessary to ensure a fair income for farmers, increase competitiveness of the farmers, rebalance the power in the food chain, climate change action, environmental care. So there is a number of things which will be partly obligation for countries, partly obligation for farmers, and there is necessary to find the way how to balance all, because in many cases they are requirements which go in the opposite direction. Yes, you need to increase food production, and you need also increase quality and safety. There is growing requirements on the food, but also we are discussing this bioenergy and other. So in some cases, if you are trying to increase one side, it is necessary to thinking how it will influence other aspect. If we will simplify all these things, we can say that for future agriculture will be necessary in the future to produce more food with higher quality, using less land and fewer inputs in the same time. So this is really something very challenges, and only way how we can do this is to build some effective knowledge management, because we are usually discussing about the data, but the data is not what people for their decision need. Yes, they need to generate information, knowledge, and then some wisdom how to solve the problems. And this is the big task for future knowledge management, to be able to use a huge amount of the data and generate some wisdom what we can do. And during last years, we developed this EUXDAT platform. You had chance to hear about this EUXDAT platform on previous webinar. And I would like now tell one issue. When we started to develop this EUXDAT platform, the main idea was that main focus will be on the end users, on the farmers, advisor, etc. But now with Green Deal, it's clear that if we have to reach, it is not possible to do this only on the side of the farmers, but we need to be able to connect it with information, public sector, food producer, with farmers, and to find the way how to share all this cost among all partners in the chain, because if we will try to that all cost for this will be paid by farmers, they probably will never succeed, because they will not see such clear benefit. And if society needs something, it is necessary that we will discuss how the cost cross society will be shared for such type of services. And we see for the future as important some type of public-private partnership, because this is only way how we can make production more sustainable, and how we can look on the problem to be able to share all these things. Here you can see the partners from the project. If you will have some question, you can write me, and I will now give the floor to colleagues from meteoblue, they will present it. They input for EUXDAT project, and also their ideas, because I like what they are doing, and I think that they can share with you a number of very useful ideas. So I don't know who will speak, Christoph, you or?
I will start, and then Nicoletta will take over.
Okay, fine. So please.
Can you see my screen?
Yes, we see your screen.
Okay. So on the platform, a few pilots and what we call scenarios were developed. And we will show you one of them, which has to do with local crop climate risk analysis, but also the ability to then in season monitor the weather and predict the climate risk for a particular crop. I'll start out with giving a little bit of context and show it on what is still work in progress in integrating it with the front end of the EUXDAT platform, what that looks like in principle. And then Nicoletta will take over and show you new results that we were able to develop within the EUXDAT project. So when you navigate to test.euxdat.eu, that is where the demonstrator is housed with a number of scenarios that you can explore. If you want to do so, you should obtain a user ID and access code, which you will get. This page is openly available for your orientation and for the orientation of users, but going further then requires an ID. We're going to look at climate risk analysis and mitigation. This is part of a scenario or combined with other scenarios that have to do with open land use and will be shown at other times. Suffice to say that there are several map layers in here made available through EUXDAT. Our interface at this point in time only uses location information. In this version, it's just the center of the map. And we're working on wiring up additional information that will have to do with the available soil types on the fields, so that those, if needed, don't have to be entered manually, but can be read off the map. There are a number of different services available. The ones that I'm going to show you just as examples are services that meteoblue had prior to the project. And then in the same vein, the services will be integrated that Nicoletta is going to explain to you and which were developed within the project. So that's work in progress. We actually have a release waiting, but it didn't get ready for this particular webinar. It's as easy as saying, okay, if we are interested in the climatic conditions at the center of this map and want to know what the cold events were over the last 30 years, we can run this. This will reach out to the meteoblue server and then return, given that we say a cold event is if it's below 1 degree and if it takes at least an hour, then we have a cold event, and we can show over the last 30 years the statistical distribution for cold events that happen in a day and number of cold events that happen in a year. We can see at the bottom the distribution throughout the years. And we also can see if we say accept a risk of 55% for a cold event happening during a day, we are basically sitting here. And that would mean if we want to be completely sure or almost completely sure we would have to, we are able to look at the time from mid of May to the end of September. Just one example, I'll give you one more. For example, looking at the precipitation history. In this particular case, we are interested in patterns where it has rained more than 5 millimeters. Of course, this looks then very, very wet. It's the same diagram. We get a likelihood for it raining more than 5 millimeters in a day. We see how this is distributed in time throughout the year and in the various years. And we have the risk for such an event happening on a particular day or in a particular week of the year. And if we are interested in much more rain, say 30 millimeters, then we can look at this as well. And of course, it looks different. What Nicoletta is going to show you is the next step that we took to combine this, not just look at the climate, which in itself may be interesting, but combine that with information on crop and interaction of the climatic patterns with the crop that we can now analyze and predict. Nicoletta, do you want to take this?
Yes, sure. I'll share my screen. You have to stop sharing, I think, because it says I cannot share. No. Okay, can you see my screen now?
Yes, we see.
Good. Okay, so yes, as Christoph anticipated, the diagrams I'm going to present are the result of the attempt to link the climate risk to specific crops in specific locations. So to make it as tailored as possible for the kind of risk that we are considering and the kind of crop that we are considering in a specific location that we are considering. In this diagram, we focused on the drought and the frost risk, but this can also be extended to other kinds of risks, for example, heat waves. And it's at the beginning, it can be quite complex. So in this slide, I'm attempting to explain exactly what the message is. So on the x-axis, we can see the cumulated degree days. They are usually used as an indicator of the growth stage of the specific crop. And for this crop in particular, which is the spring barley in this example, we've taken some values from literature based on which the crop enters different growing stages. And these growing stages are also colored in the background, in the stripes in the background. And on the y-axis instead, it's plotted the likelihood of the event based on the 35 years statistics of, for example, in this case, 35 years, but of also different time ranges. So it could be the last years, last 10 years, for example, the last 5 years, so the time range could change. So for each day, the dot on the y-axis is representing the likelihood or the frequency of occurrence of this specific event. And to each of these growing stages, it's associated an impact of the event. So a drought for example, emergence will have a different impact on the growth on the crop development than, for example, a drought at flowering. And this is why the color scale of the risk, which is the one of the dots, is actually, it can change for a constant likelihood. So for example, we can see for a likelihood of 60%, we can have a yellow risk in this growth stage between stem elongation and flowering, but also a higher risk if this is happening when flowering is happening. We think this is quite a powerful instrument, for example, to produce warnings based on historical analysis. So I'm showing a possible interpretation example of the drought graph for the same crop we've seen. And so, for example, before the starting of the season, one of these plots could be produced, and some conclusions could be drawn regarding the historical drought occurrence. So, for example, we can see that a general warning before planting could be that to avoid the most possible drought phenomena, a late sowing date would be recommended. Or, for example, along the growing season, we can issue some other warnings that the user can itself derive from the graph, based, for example, on the likelihood of water shortages and wilting symptoms along the different growth stages. And the user, the farmer, or the advisor can have an idea already of where the most critical stages can happen during the growing season. But also, it would be possible to compare the same diagram for different crops, like the ones we see in an horizontal direction, and for different locations, like, for example, in the vertical direction. So again, for this selected time range of 1985 to 2019, but it could be a different time range, we are also able to compare, for example, which crop is going to perform best, or we can also read it as which crop has the lowest combined risk in a specific location, or what's the best location to plant a specific crop. We can also, if you read it column by column, and it would be very quickly and immediate once the user has been familiar with the kind of diagram, to read this diagram, and also with just an eyesight to detect where the critical phases are. So for example, maize, we can see if we grow maize in Basel, there's almost never a high risk neither of drought nor of frost. But if we start to grow maize in Parma, then we can have a higher drought risk towards the end of the growing season. And if we grow it in Bernburg, then the highest risk is actually at the beginning of the growing season. And this is should be able to support decisions such as which crop to choose for a specific location, but also if we want to grow a specific crop, we can also play with the planting date and combine the information on one risk with the second risk in order to define the best planting date. And also it can give an idea of how many interventions would require one choice compared to another. So of course, in this case, in the case of I was doing with maize in Bernburg, in Parma and Bernburg, and a farmer that wants to plant maize in Bernburg has to take into account probably more irrigation interventions at the beginning of the season than respect to a farmer in Parma. As I said before, it's also possible to compare different periods. So the ones I showed before were related to the whole available time range that we have, 35 years. But in order to assess the effect of climate change, it can be useful also to compare different time ranges. So for example, 10 years in the past, from 1985 to 1994, to the last 10 years. And if we have a look at this comparison, we are able to, for example, to draw conclusions regarding how the risk has changed or has shifted along a season. For example, if we focus on the same crop, we can see that in the past, the highest risk of drought was concentrating between the stem elongation, tillering, and stem elongation. And now the same high risk is actually interesting a longer period, so from tillering up to flowering. And also it's possible, for example, to draw conclusions about frost. So it's quite immediate to see how frost-free conditions are happening earlier now respect to the past. Always trying to compare different time ranges. It's also possible to draw distributions to help the comparison and help also to quantify the comparison. So the same diagrams I was showing in the previous slide are now in vertical in the left hand part of the slide. And we can see, for example, if in this case, in the early growing stages of the crop, the drought likelihood is growing quicker respect to the past. So already in the early growing stages, we have a 30–50% of likelihood to have drought, while in the past this was 20 to 30%. And having a look at the distributions of the same events, so drought at the top and frost at the bottom, it's also possible to quantify somehow the change. So for example, in the case of droughts, the average number of drought days in the past was around 85, and in the last 10 years, it raised to 115 days. But also it's possible to compare how the extreme events are more or less frequent. So also the tails of these distributions are higher in the last 10 years. So there are more extreme events or extreme years. So I would like to ask, before moving to the second diagram and the second product, I would like to ask if there are any questions in particular related to this diagram.
What we have tried to do here is to make the impact of climate change on a specific crop at a specific location as visually easy to understand as possible. And I think if you look at the distributions on the right hand, they, minus the information on the crops, the climatic information that they show is exactly the same as the diagrams on the left. But you actually have to study them quite a bit and then also combine them with your knowledge of the plant in order to draw any conclusions from them. Whereas on the left-hand side, once you see how the diagram works, it can be assessed quite quickly just by looking at the patterns of the dots and the colors of the dots. And I'd be very interested to hear from some of the people who are seeing this for the first time, whether they find this very difficult to assess or whether they find it reasonable given a little bit of time to think about it. Don't know who wants to be brave and maybe make a comment off the top of their head.
Hello, this is Karel. I will try to be brave. First of all, excellent work, Nicoletta and Christoph. This is really impressive, and to be honest, this is not the first time I see this. Still, I'm struggling to learn and understand it, but it's even if I said just this, it's much more much better than anything else I saw on this topic. So yeah, that there is some learning curve, but after it's really clear to understand that after this presentation I was able to follow. So I'm really impressed of this. I have just one small question. If you go like a few slides back where you have the scale with the frost, yeah, this can be on the right. Yeah, slide number 6 probably. Yes, thanks. If I look to the first vertical scale, like from 0 to 100% risk, I think that in fact the colors are not related to the percentage of the risk, but to the impact of the risk. Am I right or wrong?
Yes, exactly. So the colors are representing the combined, the combination of the impact on the growing stage of a specific likelihood. It's in accordance to how the risk in general is defined, which is the impact by the likelihood of something. And in this case, we have associated, I will show you quickly the table. We have associated based on literature or on agronomist opinion. And so, of course, they can be improved, these tables. But at the moment, there's an attempt to associate to each growing stage an impact from in a scale from 0 to 1 of a specific event. So yes, exactly. You've got exactly the point. So the colors are providing a different information respect to the likelihood and also respect to the x-axis.
So, you know, in such a case, I would maybe consider to, but you know, because I see some orange points in the drought risk here, which are like. I don't think. I think that okay. Let me phrase it in this way. May there be an orange point which is like for a risk lower than 60% or not?
Yes. So, for example, if we had a phase where the impact was no, actually no, sorry. Because it's the product of the likelihood by the impact. So even with an impact 1, so yeah, which is the maximum impact, then if we have a likelihood of 40%, that would be a 40% risk.
Okay.
So
okay.
In this case, no. But so for example, for the same likelihood. So for example, the orange dots you were considering before. You see, we are about 60 to 70% of likelihood of this event. And when we are in these phases, so between stem elongation and seed fill, these represent quite a high risk, like from an orange one, from 60 to 80, let's say. But if we move on along the season, for example, and between seed fill and drought, then it's already a yellow risk. So the impact is not as high as in these two other growth stages. And if we move even forward, the same level of likelihood is generating a lower risk because after maturity, the drought doesn't have such a strong impact on the growth of the crop.
So then there can be like 60% change of drought, but in the later phases, it's dark green because it doesn't affect the crop, and that therefore I still don't understand the numbers from 0 to 100 on the scale, which is on the left right now.
This one, yeah, actually, these numbers could also not be numbers, and in this you're right, and I think we could also note this observation down, because in fact it could be just also qualitative description of these risk classes. So from 80 to 100, it just means that the product of the likelihood and the impact is between 0.8 and 1. But yes, actually these numbers here could also just be converted in a more user-friendly and just descriptive class indication.
Yeah, if you think of what this could be used for, you could also say, well, the green ones are no action required, and the middle yellow one is maybe pay attention, see how this develops, monitor, and the higher ones could be intervene and intervene urgently.
Yeah, I understand that. Sorry, I was maybe too in detail, but thank you for the explanation. And my comment is maybe reconsider the numbers there, because as a user, if I don't think about the numbers, I can perfectly follow like green is good, yellow. What you just mentioned, Christoph.
Yeah.
So I think it's informative. I just wonder. Maybe if you remove the numbers on the scale or replace it with some characteristics, that's what I would probably expect there.
Yeah. And then also the language around risk, likelihood, and so on is, of course, you have to stick to very, very clearly defined terms in order not to get confused. And so we'll look at this again and take up it's duly noted. I have noticed that there are people from completely different regions, like southern Italy, on the call. I was wondering, since we have 3 or 4 minutes that we could spend on it, whether they had a question and whether they would like to try this on a location close to where they are, just to see what it would look like for a plant there.
Yet if you want, I can also try to produce a graph. This is the one I'm showing. Well, actually, can you see my screen? Because I switched the window.
No, we can only see your slide.
I have to share it in a different way. Okay, now?
Yeah.
Okay. So this is actually how the back end of the service looks like, and the front end in the EUXDAT platform will exploit this service. So this is not a user interface, but from here, for example, we can produce some live diagrams. So if you have a crop between these ones that you are interested in and you would like to see on a specific location, we can also try to produce one live, just to provide an example.
Yeah, maybe I can give you Well, I can only, it doesn't maybe make 100% sense, but I can only think of Catania right now because my brother-in-law is from there.
Mm-hmm.
And that would be 37.49 north and 15.07 east.
Okay. And we can choose summer wheat.
Vineyards.
Vineyards. So the service is by default taking some default parameters. So for example, it will produce a graph for the last 10 years with the typical growing season of the crop in question. So vineyards, for example, a base temperature of 10 degrees, a soil capacity of 100 millimeters, and these thresholds for drought and temperature, and the average growing season, which is April to October. But all of these parameters can be changed by the user. So if there is better knowledge of a specific variety, for example, with a different base temperature, I don't know, 8, or a different soil capacity, for example, of the soil, so it could be 50, and also if the user has different informations on the impact that some that a specific event can have on a stage, then it can add also, now I'm not doing it, otherwise it will take some time, but it can basically create a different impact table and associate a different impact value to different stages. And then we can rerun the analysis with the updated parameters, and now we see I've decreased the soil capacity from 100 to 50 millimeters, and this is causing actually to the drought likelihood to increase. So we are already entering some yellow areas, while frost is not an issue along the whole growing season. Probably being in Sicily, it's during summer, it's also reasonable.
Okay, I think unless there are questions at this point, maybe if you want to proceed.
Mm-hmm. Okay. So I'll go back to the point where I left, and I will start introducing the second product. Was the outcome of different considerations we've done, because we have seen now how it's possible to analyze the climate crop specific for a specific location, but also it would be a valuable instrument for farmers, for example, to be able to follow the current season, and also to introduce the forecast and possibly also the seasonal forecast into this analysis. So the second product that we thought about, it's an instrument to monitor the crop-specific risk along the growing season. Again, I'm now plotting the drought risk. This time, the risk is in the background, so it's coloring the background. And on the x-axis, again, we have the growth stages. So I've reported here the same color scale that I used for the other graph, because actually the extent of these rectangles is actually exactly the extent of the growing stages we had before. And again, for each of these growth stages, let's say a different impact is considered. In this case, we are following, instead of having the frequency of the event on the y-axis, I've plotted the variable of interest. So in the case of droughts, is the available soil water for the crop. So this is different from the other graph, but this way we can follow how the available soil water is behaving along the current season. So the blue line in this example is the 2020 season, in this location still for spring barley, so the same crop we've seen before. And then at the current day, it's also possible to visualize the 7 days forecast. That's now in pink, this strong violet, let's say. And this is a work in progress, but we are also planning to include the seasonal forecast and also its uncertainty, so that a farmer can have also an outlook of the next month. And to have this is of course helpful if we want to avoid risk while in season. So it can be helpful to analyze the seasonal forecast before planting, so to have an idea of what's the best planting date, for example. But then also during the growing season, once the planting date has been decided, we can monitor the weather variable and issue some warnings about when irrigation, for example, could be needed in case we are entering a high risk area, a high risk phase, for example, or to plan interventions. So for example, when we, in the forecast, we are entering this phase, and then in case there is a higher risk, we can plan some interventions when it's possible to intervene actually. And also, it's also possible to compare the current season against other seasons or averages of the past. So in this example, I've plotted also the average of the past 10 years compared to the 10 years from the most remote 10 years, 1985 to 1994. That could also help to assess how the season has shifted during in the course of the, let's say, for example, for climate change, but also to compare, for example, a year of interest that a farmer might recall, maybe a very critical year, or a year when some events happened, and then he wants to compare the current season against the particular year. So as I anticipated, this would allow to issue some warnings. And this time, they're not based on the climate averages, but they are based on short-term or seasonal forecast. So the time horizon is a little bit different. And we can focus, for example, on the next 4 or 7 days, or to have an idea of what's going to happen in the next 15 days. And also it's possible to follow the growth of the plant and see also if it's late or early respect to what expected, for example. So yeah, it's more or less the same risk, a similar risk concept to the other one, but it's more focused on the current season. And also in this, we realize it's a bit complicated, and also this kind of diagram could require the user to familiarize with it before starting reading it. But actually, we think it's delivering once a person is accustomed to reading it. Also in this case, it would be very easy and very immediate to interpret. But of course, it would be very nice to hear your feedback on this, because now we are also used to see it. So if you have questions or comments or input, it would be very valuable for us to know.
If I may,
Yeah.
just in comparison to the previous presentation, I would say that this is as you mentioned, this doesn't need that long learning curve to understand this diagram than the diagrams before, because there is not the combination that many combinations. So I would maybe start with this one, and then yeah, just you want feedback. So this is I'm just thinking loudly.
Yeah,
it's also interesting. I always thought it was the other way around, but it's interesting that you say this.
There's not that many variables to get in. That there is a risk if you start with this diagram and then you actually change the meaning of the colors for the other diagrams. Because the drought risk again from 0 to 100%, there is just the probability, right? And
yes, it's exactly the same discussion we had before.
Yeah, okay.
We should substitute those numbers with a descriptive description, let's say, an information.
Yeah, thank you. Karel Charvát wanted to mention
I want to push people to start with questions, yes.
Okay. So I will let the floor for other people as well.
Yeah.
And thank you for the comments.
Thanks to you for your feedback.
So is there some other question? Seems that now not. Nicoletta, you have some continuation, or you are on the end?
I think I'm on the end, yeah.
Okay. There's a summary. There's a summary. Maybe give people a little bit.
Yeah, to fix some ideas, I can, I can just summarize. So basically, these two diagrams, the innovations we have tried to introduce was to assess the risk for a specific location. So to be as specific as possible to give information, and also for a specific crop, and even by a specific growth stage, and of course for different weather events. And this is meant to support decisions, for example, in long-term planning, for example, which crop to choose, but then also when to plant it, or for example, during the current season to monitor and to mitigate the risks. So for example, when it's necessary to irrigate, or when it would be advisable to fertilize, for example. And also it gives an idea at the beginning of the season of the management intensity that will be required if we plant a specific crop in this specific location. Yeah.
So we have done this for drought and frost, but of course there are other events that are important when managing a crop. Maybe in the audience there is a request what we should support next in addition to drought and frost. Well, if not, Karel, this was how much we have prepared specifically for those two diagrams. There's a lot of additional analysis and also the functionality to characterize local climate with more technical diagrams. But I think it may be good to leave it, the content of this scenario at this point, and move on with the webinar.
Okay, fine, thanks. Can you stop your sharing?
Sure.
Pavel, I would like now give on the end floor again you, because we try to collect some, to put some question and collect some feedback. So we will continue with our questions, what we started already on the beginning. So please, I would like ask you to continue with your answering. There is something like 6 questions, I think, or something.
I believe there is 10 in total. So
10?
we,
okay.
Yeah. So 7 more.
Okay. So it seems that the reactions are optimistic. We can move to other question. I don't know if you heard about Destination Europe. It is the building of a global model of European agriculture, climate, and other. So this is something what is running parallelly with Green Deal, and it is mainly focused on the technology to build some digital twins for Europe.
Sorry, can you put the link for voting in the chat? Because I lost the link from yesterday.
Yeah, sure. I will copy paste it once again. There we go.
Thank you very much.
My pleasure.
Okay, next. Here you can vote for more things, yes.
Great, we can move on to the next question, as I see. Okay. The next one is the purpose of using the infrastructure. Again, you can choose multiple options. And we are about to have last 2 questions. The second from the end is one with multiple choices. There we go. Okay, thank you very much. And the last but very simple question is this one. And this is the end of our voting. Thank you very much for participating in the voting from my side. Thanks a lot.
Okay, thanks, Pavel, for making this analysis. I would like to thanks to presenter Christoph and Nicoletta from meteoblue for their very nice presentation. I think that it was useful for many people, and I believe that we will meet with some from you again tomorrow, because tomorrow we continue with other program. It is already at 10 o'clock in the morning, and the focus is on agroclimatic zones and field accessibility tools and components. First presentation will be done by Karel and Pavel from Wireless Info, and then will be presentation from PESEL instrument. So then on Tuesday afternoon is last presentation, which will be focused on open land use map. You heard about open land use today also in relation with this scenario, so you will learn more about open land use map, and then will be crop monitoring pilot from CERT. So this is the program for next day. I hope that the program will be for you interested, and that we will meet again in the next day. So I wish you the rest of good afternoon for today, and please follow our web pages. There will be additional information, and there will be also publish all these videos and other information which could be interesting for you. If you are interested to cooperate in the future, please contact us. So goodbye.
Goodbye, and see you and hear from you tomorrow 10:30. Thank you.
Bye. Goodbye.
Goodbye.
Yeah.
Thanks.